Okay, project for the day. Haven't done a vintage computer video in a while, and I have this Mattel Aquarius personal computer. Not a terribly successful model, but I don't think there is anything really inherently wrong with the design. I think it was one of those things that was too little too late, or at too high a cost, or just outclassed by the competition, but still nothing particularly bad about it. Very basic personal computer. Has at least it has discrete keys. It's not a membrane keyboard, but it's got those kind of rubbery keys, so it's not like you're going to touch type on this. Has connection for a proprietary printer and a proprietary cassette recorder. It has a internal video modulator where you can select channels 3 and 4, and a modulated video output for the TV set, either again on channel 3 or 4, but you do have to use a adapter box to tie it into the antenna, which I don't have pictured here. And there's a expansion slot here for memory expansion or game cartridges, that type of thing. And great big heavy brick power supply. And the problem I have with this, even though it seems to be brand new, it came in the box with everything and it was all wrapped up and unblemished. I don't think it was ever used. Maybe somebody got it as a gift or something and then used it a couple times and put it away. Beats me. Anyway, I have nothing that will hook up to this. I don't have any old-fashioned TVs or anything that will even receive a antenna type video signal. And I've done a little poking around online and realized from that there's a composite video signal and a separate monaural audio signal available inside of here at conventional levels, and all I should need to do is to disassociate those signals from the internal video modulator, put another jack or two on the back here, and with that I should be able to extract those signals. A couple other websites said that to get the best video quality it is really necessary to put a buffer video amplifier or a video signal buffer on the video output, or it gets loaded down too much. I have a little bag here I purchased online of Maxim 4090 video buffer chips or video amplifier chips. I'm not sure they have any provision for gain. They may just be buffers. Anyway, it's something that other people have used. The downside is that it's on a surface mount chip, which I'm normally not set up to deal with. So I got these Adafruit surface mount breakout circuit boards, so at least I can solder one of these things to one of these boards and then have more conventional holes on there to tack on. I found a schematic online for the Aquarius, and this is the chip here that generates at least the video, if not the audio. And here's a blow up of it. So the video signal comes down there, has a resistor divider, and then it goes into the video modulator on pin 1. 12 volt power is supplied to pin 2. Sound signal comes in to pin 3, and then the modulated output comes out there, and that's all there is to it. So there should be 3 terminals, and it should be pretty easy to identify them. The video buffer circuit's the Max 4090. This is the schematic that they recommend. So they recommend putting in a voltage divider circuit on the input, 275 ohm resistors, and then a capacitive coupling to reject any DC component of the signal. goes into the input pin. VCC and something called SHDN go to a plus 5 volt signal, which there will be on the Aquarius circuit board somewhere. And then there's a feedback signal and an output signal. And that may be how this thing can have gain. If you put a resistor between those, that would cause it to have a gain of greater than unity. But if you just jump them together like this, then it's going to be a buffer. And then they show putting a 75 ohm resistor divider here. From what I've read, those resistor dividers are not necessary to get a decent result, but the capacitive coupler is. So I think all I need to do is tap off of the wire that goes to modulator pin 1 and put it directly into the capacitor here, capacitor into the chip, tap off the 5 volts on the circuit board and ground, and then come right out of pins 1 and 6 tied together and go straight to the video output jack. And then the audio output should be pretty close to line level, I'm thinking, if I just tie a jack directly into this point right here, will probably be adequate. Should be able to run a set of computer powered speakers or anything like that. And look at those tiny little Max 4090s there. Gosh, those are small. And I'm not sure that I picked the correct breakout board because they look like the pin spacing is smaller. I'm so unknowledgeable in the different forms of surface mount. This appears to be an even smaller than the normal SMT, but it's possible I can still make it work. The spacing may be just enough that I can tack it on that way. We'll see. Otherwise I'm going to have to put on my microscope and see how steadily I can hold my hands. That's really small. So there's the case top with the back of the keyboard and a shield that goes over the cartridge slot. And then this is the main circuit board, and it's got all these soldered on shields over it, so it's not going to be too easy to get in there and look at the top of it. I did find a circuit board layout diagram on the internet, and I don't need to have this to know that this is the video modulator. And somewhere around here is a voltage regulator. I don't know where it is, but this is the incoming power, so it's probably around here somewhere. Oh, this is probably where it is. There's looks like a 7805 screwed onto this metal frame, and it's got looks like 3 wires going to it. That's probably a 7805 there. And there's the schematic for it. It shows a little double choke capacitor circuit. I don't know if that's part of it down there or not. It's in the right vicinity. There seem to be 2 of those. 2 chokes and then a capacitor. I see 2 pairs of 2 chokes. I don't necessarily see the capacitors, but they might be down there somewhere. And then the power switch is way over here. But otherwise you've got, this is a 1000 microfarad capacitor here. And off the top of my head I'm not spotting a 1000 microfarad. These are both 1000 microfarads, just different voltage ratings. They're on there somewhere, but I'm not necessarily spotting them on this. Wait, this is 10,000 microfarads, and this is, 1000 microfarads. Okay, so that's this cap and this cap right here. So they're referring to millifarads here, not microfarads. So that would do that. Okay. Well, almost certainly that's the voltage regulator down there. I'm going to try to get the circuit board out now. Alright, so the circuit board is loose from the case. And I can flip it over here. You know, it's not a badly designed unit. It's not just tin foil inside the case. It's got nice heavy sheet metal shielding, and the case weighs a lot. It's not going to slide around on a desktop very much. Somewhere down there these power supply wires go down under the can. I just have to isolate where the 5 volts is. And I did verify that's a 7805 down there. Look at that. They helpfully labeled the trace as 5 volts. So right there in the middle of the picture is the 5 volts. It's right next to one of 3 terminals. So it looks like originally they had the circuit board laid out to maybe put the 7805 right there on the board, and then decided to relocate it. But on the other hand, there are stampings on there on the frame that make it look like they intended it to be there all along, so I'm not sure. Anyway, it's pretty clear they just have 3 wires soldered into those 3 pads, and then they extend out here. So it should be pretty easy to trace that 5 volt signal up in this general neck of the woods and tap off of it. There's even a, you know, there's clearance around it to run a wire from the back side to the front side if I have to. I don't really want to take that whole shield can off the front if I don't have to. And did I mention I haven't even tested this yet? I might be doing work on this on a dead computer, but it sure looks brand new, so I bet it was never even powered up. So I've got the computer powered up here, and just trying to make sure I understand what's what on here. The first pin on the very left of the modulator here is actually connected to the switch on the back, which selects between channels 3 and 4. And it's kind of like this, as I've drawn it there. When the switch is in the channel 3 position, it grounds that pin of the modulator, and when it's in the channel 4 position, it brings that pin of the modulator to plus 5 volts. So a voltage shift there determines the frequency of modulation. And I verified that the second pin over has plus 12 volts on it, as I've marked the shield right next to that pin. And now I'm going to the rightmost pin, and it's clearly got a video signal on it. And the computer must be alive because it's changing what's there. It's not just a static pattern, it's changing something. I don't know exactly what, we'll find out, but at least it's some confirmation that there's something going on inside this computer, and that I know that's the video jack. Now the other thing's got to be the audio, and I don't know if it's putting out any audio at the moment or not, but it doesn't seem to be. I would expect to see something going on there, but maybe it doesn't make noise unless you push a key or play a game or something. So I'm going to have to presume that that's the audio input, because it can't be anything else. Alright, so since I haven't done any surface mount work before, I had to buy a couple of things to do it better anyway, with more chance of success. First off, I wanted to get some finer solder so I wouldn't be flooding the small joints with the thicker solder I use, which is already pretty thin, but I think it's a little thicker than I would like for this application. So I still wanted to stick with 6040, and I got this solder here, which is a 0.015 diameter. This is the DigiKey information. And this is the roll, 60/40. And let's see. It's a no clean water washable flux core, even though it's really pretty tiny stuff. So there's that. And I got a couple of smaller tips for my soldering iron. I've wanted to get a couple smaller tips of different shapes for a while, but always just forged ahead with my normal tip. So this is the DigiKey information for one. It's a Weller part. And this is the other one. So that's a fine tip with a bit of a bend to it. I thought that might be useful. It may actually be bigger than I need, or smaller than I need rather. We'll see. There's the other one. It's really the same thing without the curve and without the length. And then there's some solder wick, some fine solder wick. I usually don't use solder wick or keep it around because I use a solder sucker and a desoldering station. But for this I thought it might be nice to have some small size desoldering braid. So that's that. And a set of tweezers. I have a larger tweezers, but I thought I wanted a smaller one. And some no clean flux. So this is apply flux on all pads, place surface mount device on pads, press it down with a pick or tweezers, with a tinned iron tack down 3 or more pins, with a flat chisel tip iron, apply solder as required and drag solder across all pins. If a solder bridge is formed, use flux and solder braid to remove bridge. Clean solder joints with isopropyl alcohol. So that's what comes with that. The syringe, the plunger, a cap, or maybe that's a plastic needle. That's a plastic needle and a metal one. And the instructions on a nice laminated card. And finally some SOT23 to dip adapters. I had these other ones here, these Adafruit ones that I bought on Amazon. These are surface mount types, but they're the wrong package type, and their pads are too far apart slightly to line up with the surface mount parts I've got, so I actually looked it up and found that they were actually SOT23s, so I got these adapters. And they're designed to break it out to a normal dip spacing like you'd have on a normal IC. So that should work pretty well. Got 4 of these. They're I'm not sure what the brand is, but that's the DigiKey stuff. Got the adapter on my Panavice. So there's the fine point straight tip in my soldering pencil. There's my assembled flux syringe. I even got one of these things off of Amazon to put in front of my eyeglasses, so all 3 of these combined only gives me a 10 times magnification. My jeweler's loupe gives me a 20 times, and my work lamp gives me something less than that. I'm going to try this out and see if I can see the part a little better using these. just about impossible to see on the video, but I do have one lead of the IC tacked down already. That was successful. And I made a backup. This one was actually a lot harder. Maybe the first one was beginner's luck, but I just had a heck of a time getting the chip to stay centered on the pads with the tweezers. You know, I'm older, I'm not as steady with my hands. It was difficult to brace them, and it just kept jumping out of position. I had to struggle with it for probably 15 minutes before I finally got it locked down in the right position. Then the soldering went just fine, and I actually did a slightly neater job of soldering on the second one. So now I think I'm going to move on to the testing. While I was waiting for my regular soldering station to cool down so I could change tips, I got out my trusty old Weller soldering gun that I bought as a teenager, probably in about 1972, something like that. Rarely use it, but it's nice to have. Can't kill these things. And it's just to get rid of these big blobs of solder that secure the mounting tabs to the video modulator. And while I was at it, I undid the unsoldered the 4 leads going into the modulator as well. Okay, that's the back side of the board with the video modulator desoldered. And there's the front side. And there are the 4 pads for modulation, frequency, control voltage, plus 12 volt supply, the audio pin, and the video pin. And there's the video modulator. And over here on the corner of the board, where the wires from the 7805 voltage regulator come into these 3 pads, this is the 5 volt power rail that goes up here and goes along here. So I've just scraped a little of the solder mask off and tacked a longish red wire on, which I'll take around the other side of the board to power my new video chip that gets at the 5 volts. Now I have to find a good ground point. I think probably it's just this right here, but I'll do a quick continuity check to make sure. Yep. Definitely this is the ground here, so I can probably tap off like this one or this one. That'll be convenient. So now I've got the red wire coming around from the back. I've got 2 black wires going into this. The solder didn't take here, but the important side is the back side, and that's soldered in nice. So one of these is to go to the video chip, and the other one is to go to the AV jacks that I'm going to mount on the back. So I've got a blue wire going into the video pad and a white wire going into the audio pad. I don't have any yellow wire. That would have been better for the video, but oh well. I realized that I'd broken the plate through holes, if there were any. There might not have been. They might have just been punched slots for the tabs on the video modulator. But I decided that since it's intended to have through-hole there, through-hole continuity, I'm going to just solder some little pieces of bare wire in there and then fold them over and solder them on the other side. Can't hurt. So there's connections I've made to the holes on the adapter board, the breakout board. I've got my 0.1 microfarad axial capacitor going into pin 3. And I've got a jumper between pins 4 and 5, which is the 5 volt input, and I've got a jumper between pins 1 and 6. Pin 6 is the feedback and pin 1 is the output, and by tying pin 1 to pin 6 it makes it into a unity gain buffer. If I'd put a resistor between those 2 pins instead of the jumper, then this little video buffer would become a video amplifier. But based on other information I found online, I should be able to work pretty well with this in a unity gain configuration. Okay, I've got a stripped audio output lead, a stripped ground, a stripped blue lead from the video output of the buffer, and I've got everything connected up to my little board. So now I need to do a sanity check before I start cutting into the case to mount the two RCA jacks. Okay, I've got things temporarily rigged up to my little monitor. Moment of truth, what's going to happen? Ooh, push routine, it's working. Son of a gun. And the text is pretty clear. But I don't have my keyboard plugged in, so I can't do anything. I'm going to try that next. Before I'd noted how there was a periodic change in the video signal when I was monitoring it, and that's because of this background color change. I figured it was something like that. But the video buffer chip is working. Okay, so there's already a hole for the video output, and I'm just going to have to drill another hole of similar size just so it looks appropriate over here a little bit, and then I'm going to put a metal plate behind it that's actually drilled for the right diameter for these RCA jacks, and then I have to find some way to attach that securely to the back of this. It'll probably involve a couple of screws. I probably could epoxy it. I have a lot of doubt that that's going to be strong enough, so I'm probably going to use a couple of screws. I've got my holes laid out on the back using Sharpie markers. I've got a couple 440 cap head screws, an appropriate clearance and tap drills, and a 440 tap. And I figured I need a 2 5/8 by 13/16 piece of aluminum. And as I've mentioned in some other videos, these aluminum plates come off of a Radio Shack project box that I used to use tons of, and I didn't usually use the aluminum plates, so I just kept them, and they're great for heat sinks, little metal brackets, and everything else. I've got a whole box of them. With the dimpled holes hammered flat so it'll fit into the metal shears better, I've marked out my cut lines. Okay, it's marked for drilling. So there's my aluminum plate screwed into the back. And the way it looks on the outside, looks like I screwed up my center somehow on this, although I think it'll be okay. I just have to do a quick check and see how close to the edge it comes. If I have to trim it, I will. Well, it does fit, but it looks ugly. Maybe I'll make another metal plate. Okay, I've got my new metal plate in there, and let's see how it looks from the outside. Well, it's still not centered very well, but it's centered better. I'm just drilling these holes by hand and stuff. It's not high precision stuff, and with my old eyes and so on, sometimes I don't get these things centered quite right. Anyway, it's good enough. Certainly better than the first attempt. So now I got to plug the keyboard in, make sure everything's still working, and then button it up. And there are the wires soldered to the connectors and tucked kind of down and away. And the circuit board's really held in place by the stiffness of the wires, but I've got a little piece of double-sided foam tape, or yeah, double-sided foam tape is what it is, kind of anchoring it in that one position so it doesn't flop around so much. Okay, the computer is back together, and I'm going to turn it back on. There we go. So basic, press return key to start. Okay, there's that. I'm going to type 10, 4, I equals 1, 2, 10, 20, print I, next I. See if it follows the normal conventions. Okay. Okay, that worked. It's not a great looking display, but it is legible and pretty stable. I did run into a snag, not shown in this video. I had everything hooked up, I verified good connections, good continuity, good solder joints, but I had a lot more noise on the screen when I was using both the video and the audio cables on that same aluminum plate, and I got better results when I isolated the video from the audio ground. I'm not sure why, but what I ended up doing was just soldering a RCA cable onto the ground plane and the small amplifier circuit board for the video amplifier, and then just running the cable out the hole in the back. In that sense, it's no different than the power cable, which also can't be unplugged. It's not the way I wanted to do it, but it seemed to alleviate the issues I was having. It's possible that I could have broken that aluminum plate into 2 halves, but all I'm really trying to do is demonstrate this computer, and I can always go back and do that again if I want to later. Anyway, I have to look in the manual now and see what else I can do with this. Okay, I have the Aquarius data recorder. Here I put a tape in. I hardly have any cassette tapes anymore, and I actually put in a XL2 90 minute. It's not really the right type of tape, but hopefully it'll work. I don't have a power light, and I would think I should. This cassette deck actually has to be plugged into AC, which it is, and also into the connector on the back, which it is. And I've got a program in there, so I should have to type csave and then test. So I'm going to type in csave and so I've got csave test, and then press return, and it should tell me what to do. Press record, press return, key to start. So I've just pushed the record button and press return to start. Well, the instructions here say just to push record, but apparently I need to push play and record. Okay, I've rewound my tape. I'm going to see if I can... I don't know if you can cursor up on this thing or not. So I'm going to type csave test again and push enter or return. I'm going to push play and record. And push the return key to start. Okay, it says OK. So according to the instructions, it's done. So I'm going to type in new, return, list. There's nothing there. I'm going to rewind my tape slightly. Okay. So I'm going to type in C load test return, and it tells me to play. I push play and hit return. Found test. Okay. Let's list it. Okay, how about that? It worked. There's some life left in this bugger still. Now there is a overlay piece of plastic which I think gives you some shortcut buttons that you can type the key. I don't know if you got to push shift. Oh, it's like a no. Basically, I think it allows you to not have to type all these basic commands, but it doesn't fit properly. And the way I got it, it was all warped like this. I tried to straighten it out with a heat gun, didn't make it any better. And if I put it on there, it binds the keys, so I'm not going to use it. Doesn't look like it's necessary to use anyhow. I'm going to do another save here, same program. I'm going to call it Test 2. And I hadn't had my audio output plugged into the speakers on the monitor, so I wasn't hearing anything. I want to see if that output works, so I'm going to push return. It says do that. Okay. I didn't hear anything. Also, the red light doesn't work on here. There's something off about this. It should work when it's doing that. New list. See load test 2, return. Press play. Push return to start. This is an incredibly slow tape counter on here. I don't know if it's malfunctioning or if it's always that slow, but if it is, it's several seconds between each number change, so it's not very useful, except as a very general way. So that got that. Yeah, there was no red light and no sound. I don't know what's going on with that. Well, at least the save and load works, but it doesn't seem like I have any sound. I have no idea why that is. I suppose it's possible I've got the sound on the monitor turned down. I've put in this little poke command in immediate mode. I'm not sure what it's supposed to do. Something with the color. Oh, I put a little dingus up there. Guess that's all. It says, this tells Aquarius to poke the foreground color, violet, and the background color, yellow, into the home position. So 13552, 13352 is the number for the home position. What if I poke 13353, comma 5, okay, I got it in one bigger number, and yep, it did the same thing. So I guess that's supposed to be violet. It's kind of violet. So at least the color is basically working. Didn't really have any doubts. So here's a little program from the manual. I was trying to find something that would do something with sound, and that apparently is the command. So this specifies on line 20 a high-pitched tone for a duration of 80, and then on line 30 it specifies a slightly lower tone for a duration of 50. So let's see if I get anything. I've turned the volume up on the monitor. I don't hear anything. Huh. Yep, I've got no sound. And I didn't have it before when the computer was open and I was putting the oscilloscope on the sound line. So I don't know if the part that generates the sound died. I'm not about to open it up and troubleshoot that, inconsequential to basic demonstration of the computer. Anyway, I think this has been a successful project. I've got a reasonably clear display. It likes to go glitch every so often, but at least it's an improvement, because without this modification, putting in a little circuit like this, I wouldn't have been able to even power this up and demonstrate it at all. Not having a TV or anything that can accept a RF modulated TV type signal. So I hope you found this useful.